Hello students, welcome you all to my YouTube channel. As you know, this channel is for ICSE physics, mainly for high school level, and every time I'm coming near you with a new video. Today, in this video, I'm going to discuss about types of vibration, and in this, we'll get different characteristics, different examples related to the vibration. As we know, sound produced due to vibration. In our first video, we have discussed some aspects of sound, some properties of sound, and how we can differentiate between two sounds based on their loudness, based on their pitch or quality. Okay, we are going to discuss about that types of vibration. In this type of vibration, the first type of vibration is the natural vibration or free vibration. What we can say is the free vibration or natural vibration. Whenever any object is start vibrating, because we know a body will not change from rest to motion or motion to rest without the application of external force. So when a body gets some external force, it start vibrating, and if its amplitude will remain same, if it will not change uh, during the vibration, if its frequency remains same, if its amplitude remain constant, then we can say this vibration is a natural vibration. Natural vibration is different for different type of objects, and this one possible only when there is no external force to stop the motion or to stop this vibration. Only possible in vacuum where there is no air present. Natural vibration time, when a body will vibrate, as we know in the vibration, number of time a body vibrate is called frequency. So natural vibration time, how much time a body will vibrate in 1 second, it is called natural frequency. In the absence of any driving or damping force, means opposing force. And this natural frequency is different for different type of material, different shape of material, different mass of material. So it will come to the uses, or it will come to the example of this free vibration or natural vibration. What I'll get in case of simple pendulum. Simple pendulum, you know that a metallic box connected with a thread and hang from a rigid support which is free to move. Once it displays, when we'll push slightly, it start vibrating to and fro, means from mean to extreme, extreme to mean. So this one depends upon length of the pendulum, and second, the acceleration due to gravity. As we know, time period directly proportional to length and inversely proportional to acceleration due to gravity, and time period equal to 1 by f, means frequency is inversely proportional to length and directly proportional to acceleration due to gravity. So in case of simple pendulum, we'll get two factors: one, the length of pendulum, and acceleration due to gravity, which will decide the natural frequency of a simple pendulum. Second case, if we look in case of a string instrument, we know string instruments are the instrument where metallic strings vibrate to produce musical sound. In that string instrument, first thing, the natural frequency depends on the tension, means how much tightly all the strings are connected. Second, radius of the string, means it is thicker one or thinner one. More the tightness of the string, more frequency, means directly proportional to tension. Less the radius of the string, more the frequency, that means inversely proportional to radius. More the length, less the frequency, because they are inversely proportional to length, means it depends upon tension, it depending upon radius, it depending upon the length of the string. And another one, if you look here, when a load is suspended from a spring by using a spring and it start vibrating, that time it depending upon stiffness or force constant of that spring, means how much tightly or loosely that spring all rings are connected, and mass of the load, means now we got that natural frequency is depending upon length, natural frequency is depending upon the mass, means In a string instrument, if we look, all the strings used there of different length, different thickness, different mass, because to produce different type of frequency or the sound with different pitch. For that reason, you might have seen who are using string instrument, they are changing the position of their hand. So by changing the position of this finger, they'll change the length of vibrating string, by which they can produce different sound or sound of different frequency, different pitch. So another one, if we look here, vibration produced by flute or mouth organ. In that flute, if we look, it is having different holes, and who are playing that flute, they change their finger to close or open the different number of holes to produce different type of sound or different sound with different frequency. That's because uh, vibration depends on the length of air column. More the length, less the uh, frequency, less the length, more the frequency. This one will get whenever you will put a bucket or one bottle down a water tap. Once the bucket or that bottle is going to fill, now length of air column gradually decrease and the sound will become more shriller. Means the sound will become more having more pitch, or we can say the sound is having more frequency. Here you can see three type of vibration. First one, if we look here, it is having maximum amplitude and minimum frequency. Here, that frequency increase, amplitude decrease. And third case, if we look, frequency more, but the amplitude. This one, it will come to the relation. In my first video, if we look, I've discussed about the relationship between frequency and wavelength. F1 lambda 1 equal to F2 lambda 2 means if we take the ratio of wavelength here, one case, first thing like to look the ratio of frequency. Here 1, here 2, and here 3. Means if we look here, the frequency ratio 1 is to 2. That means wavelength ratio is 2 is to 1. Means here the wavelength is 2 times more in compared to the second one. If we compare 1 and 3, then here frequency is 1, 2, 3, 4. Means 1 is to 4 the frequency. Means 4 is to 1 is the wavelength. Means here the wavelength is 4 times more in compared to this one. Means frequency and wavelength inversely proportional to each other. More the frequency, less the wavelength. Less the frequency, more the wavelength. This one also we can say as the example of principal note and the subsidiary notes, what we have discussed in our first video. Next type of vibration we can say is the damped vibration. Damped vibration means whenever a body starts vibrating due to the force given by the surrounding, or simply we can the frictional force, because of which it stops after some time. And this type of vibration is the damped vibration. Means amplitude gradually decrease. If will hit to a school bell once only. Once you will hit means the sound of the larger amplitude will produce, and gradually the sound will stop. If you will hit with a metallic bowl, it will produce the sound, but fast it will produce with the higher amplitude, and gradually the amplitude will decrease. So this is the damped vibration. And damped vibration, because of frictional force, and that force which decrease the amplitude of vibration is called the force of damping. On another type of vibration, that undamped vibration, where there is no effect of any external factor like friction. Here you can see the graph. In this graph, first the amplitude high and gradually the amplitude decreasing. Means magnitude of damping force acting on a body is directly proportional to velocity of vibrating body. Means more the velocity of the sound, or more the velocity of the vibrating body, that time we need to apply more force to stop, or if it is slow, where we need some less force. Another one, if we look here, the loss of energy leads to continuous decrease in amplitude of vibration. Means the energy degradation or dissipation of energy is responsible for the decrease in amplitude of vibration or sound. Gradually will start with the higher volume and gradually it will ceases. The frequency and time period of vibration remain unchanged. Means there is no change in the frequency or time period of vibration during this damped vibration. Means damped vibration is that vibration one time only you will apply the force, It will produce the sound with a larger amplitude, and gradually the amplitude decreases and sound ceases. Next one, if continuously will apply the force, like in the mainly drum case, the whole case, we are applying the force continuously, then what will happen? That is the force vibration. Force vibration time. Body is said to be execute force vibration when it vibrate under the influence of external periodic force. Means continuously we are applying the force and the body will vibrate. Once the force stop, vibration stop. All the vibration require force. Simple free vibration, natural vibration case also they need force, but it is very less. Then vibration time they need only once the force. Force vibration time they need the force continuously. Force vibration time. External force which cause this vibration is called a driving force, because of which a body will start vibrating and will continue its vibration until the force applied on it. Another one, if you look here, force vibration, because of which, and we might this one we heard in English also, empty vessel sound more, means a hollow sound box will produce more amount of sound. Why? Every time in a string instrument that is having a number of strings with length different, sometimes it is having the radius different, sometimes it is mass different, and they are having a hollow box. Inside the hollow box it is having air, and once the string vibrates, that vibration will pass to the air. A number of air particles present more inside the hollow box, which will produce larger sound during forced vibration. When this forced vibration having the frequency or force vibration time, when you are applying the force, different type of vibration will get in that frequency differ, amplitude differ. Once the frequency of force vibration will be, once the vibration or force vibration frequency will be equal to the natural frequency or frequency of natural vibration of that body, will get a term called resonance. Resonance is that force vibration or special type of force vibration in which frequency of the vibrating body is equal to the natural frequency of that body, and two conditions required for this resonance. Resonating body must undergo force vibration, means we must have to apply the force to vibrate the body. Second thing, frequency of external periodic force must be equal to the natural frequency of the body, then only resonance occur. And because of resonance, high amount of sound produced or the amplitude of vibration will be high. Here, people see some examples of this resonance. And experimental demonstration means we'll demonstrate now the presence of resonance by taking different type of object. First one, we'll discuss by taking a number of simple pendulums. Demonstration of resonance with pendulums. Here you can see 5 pendulums marked as A, B, C, D, E. Some are of same length. If we look here, big, some are smaller one, some are little bit more length, some are less length. Once they will start their vibration once it will start means all the simple pendulum will start moving true and pro, or true and pro movement, we can say mean to extreme, extreme to mean, they will vibrate because of external force. Once they will start vibrating, if two pendulum are having the same length, here you can see A and D are having the same length or equal length. Equal length means if we are using same material, same mass of bob and same length, means their natural frequency is same. If the natural frequency is same, then A to D and D to A, the energy transformation will take place, because of which when D become maximum, A minimum. When A become maximum, D minimum. Means energy is transferring from A to D and D to A. This is only possible when both are having the same length, when both are having the same mass, when both are made of same material. And other all will vibrate in their own way, but A and D will transfer energy between them. That is only because of resonance. Another one, it will take another experiment by taking tuning fork and sound box. Here you can see two tuning fork attached to two sound box. Here you can see two sound box, this one and this part, for one end is open. People hit with a hammer to the fast turning fork. It start vibrating, and this vibration will transfer to the air box or sound box. The air inside this box will start vibrating, and through the open end the vibration will pass to the second one. The sound wave will go to the second part. And this sound wave, when it will pass to the second sound box, this tuning fork B also will start vibrating because of sympathetic vibration. Sympathetic vibration means the resonance. Resonance, also known as sympathetic vibration. So resonance is a special case of forced vibration, which is also known as the sympathetic vibration. Means because both are having the same length, same material, same diameter, for that reason, when the forced vibration frequency will match with natural vibration frequency, resonance occur. And because both are having the same length, same material, same mass, so resonance will occur and a large sound will produce in the second part and the B part. Means one means in the A part we have given our force, A start vibrating and the vibration transferring to second one because of the resonance. And people come to the uses of this resonance, means where we are using. First one people look. First example, resonance in musical instruments. Musical instruments are different type of musical instrument in that. Guitar we are having, sitar we are having, cello. All these musical instrument having different string. This string when it will vibrate, that vibration will pass to the air column inside the hollow box. And that hollow box having number of air particle more. Once the forced vibration frequency and the natural frequency of air particle match to each other, then resonance occur. And because of resonance, high amount of sound or high intensity sound or a loud sound will produce or sound of more amplitude will produce. Second one, in case of wave receiver or radio channels, TV channels, all are having a definite frequency. Means you have to set the frequency to get the sound from that satellite. In radio channel, we have to set a frequency by using the knob, by using the tuner. So once the frequency is set with the natural frequency of that radio channel or TV channel, we'll get the sound. If we'll take in Balangi radio station, it is 101.9 MHz megahertz. So they'll produce the sound. Here you can see another example. In this example, we'll get a resonance of a machine part. Whenever bike or scooty is going in a definite speed, all the parts which are little bit loose will start vibrating and they will produce a sound. This sound, because of the resonance, means when the speed change, the frequency of vibration of all the parts also will change. Any part natural frequency and the frequency due to forced vibration will match, will produce the resonance, because of which they will now move or they will now vibrate with larger amplitude and they may come out. So what we can do to solve this problem? We have to change the speed. Either we can increase the speed or decrease the speed. But most of the time it is advisable to decrease the speed so that that knot or that screw or the mirror part which is producing the sound or which is vibrating in a larger amplitude will stop. Next one, equally. In case of a suspended bridge, when soldiers are moving from one part to another, always they are going in a rhythm. So when they will go to this type of suspended bridge, the troop is ordered by the commander to break that march, because once they will go through the suspended bridge with a uniform vibration, that time vibration due to the force or force vibration, and if the frequency of natural vibration become equal, then it will produce resonance, because of which the bridge now will vibrate with more amplitude and the soldiers may fall down. it may cause accident. So these all are the example of resonance. Here we got different types of vibration, and also we got the properties, characteristics, example of different vibration. So to get more uh, videos of physics, you like my video, if you will feel it is important for you, helpful for you, give your comment in the comment box and subscribe my channel for